These are the 6 notes. We talked about what a matrix was today in class, and so this is the notes that will introduce what they really look like. First thing we're going to talk about is what is a matrix, or matrices is the plural form. A matrix is a rectangular arrangement of numbers in rows and columns enclosed in brackets. So I want you to take a look down here. This makes a rectangle if you look at it. Numbers in rows and columns. And then these are the brackets that they're talking about. So we're going to say a rectangular arrangement of numbers using rows and columns. And in this chapter, we've been talking about systems of equations where that's 2 or more equations. And we talked about it in class where we could start organizing really big systems into matrices to make them a little bit easier to deal with. And each little piece or each number in a matrix is called an element, just like a set. So each number or variable in a matrix. Okay? The dimensions are read row by column. So if we're looking here, we have 3 rows and 4 columns. So the dimensions of this are 3 by 4. And when we write this, we're going to say row by column. So when we start naming matrices, like we said in class today, we start giving them names, usually capital letters. So I would read this matrix A. These are different elements, the ones that are circled, 5 and -1. Now all of the numbers are elements. These are the ones that we're just going to use as an example. This one is in row 1, column 3. This one is in row 2, column 2. Okay? And it has 3 rows and 4 columns. Matrix A is a 3 by 4. It has 3 rows, 4 columns. So we're going to go ahead and just take a look at these matrices on the exam or on this page, and then we're going to identify the position of each of the circled elements. So this one has 3 rows and 2 columns, so it's a 3 by 2. The position of the circled element is first row, or you could say row 1, second column, or column 2. Okay? I want you to quickly go ahead and do B, C, and D on your own. Pause the video, I'm going to keep going. This is a 1 by 4, and it is in row 1, column 3. This is a 2 by 3, and it is in row 2, column 2. And this is a 2 by 2, row 2, column 2. Okay? Turn to the next page. So we can take systems of equations or graphs of data or tables of data and organize them in a matrix in order to make them a little bit easier to understand. When we do that, you just put in your brackets. Now this one's going to have 3, so I have to make sure my brackets are big enough to have 3 rows. So 10, 5, and 8. Then go across, but you have to leave a little bit of space because they're also organized into columns. So 8, 5, 10, 8, 10, 5, and 10, 8, 5. Now this is great, but if they were to give me this matrix, I would have no idea what it means because there are no labels. You should add in labels. So we're going to say north, south, and then we're going to put Jefferson, and then freestyle, backstyle, breaststroke, and then butterfly. Okay, now it would make more sense, especially if we had a story problem. Okay, I want you to go ahead and do part B by yourself. It gives us a story problem instead, but you would be able to take this and put it into a table. So if it helps, put it into a table first, then put it into a matrix. But if you think you can go straight from here to the matrix, that's just fine. But I want you to go ahead and try this one on your own. Pause the video. So it says, for a matinee, a movie theater charges $5.25 for an adult and $4.50 for a child. Evening admission is $8.75 for adults and $5.75 for a child. Organize the prices into the matrix. What are the dimensions of the matrix? So I know I'm going to have two different prices for adults and two different prices for children. And those prices are $5.25 and $4.50, and then $8.75 and $5.75. Now, we're almost done with the labels, but over here we have to decide, well, what's the difference between this row and this row? This was for a matinee, and this was for the evening. Okay, so what are the dimensions of our matrix? It is a 2 by 2. All right, turn to the next page. If two matrices have the same dimensions, they can be added. Simply add the corresponding or the same position elements as of the matrices. If they do not have the same dimensions, they cannot be added. So take a look. A, B, they both are 2 by 2s. They could be added. B and C cannot because they have different dimensions. So let's start with A plus B. I'm going to have 12, 2, negative 9, 15, plus negative 4, 4, negative 3, negative 10, equals, now because they're both 2 by 2, when I add them together, I will get a 2 by 2 out. All I have to do is take the two corresponding pieces and add them together. So position 1 for A is 12 and position 1 for B is negative 4. Add them together. 12 plus negative 4 gives me 8. Negative 9 plus negative 3 gives me negative 12. 2 plus 4 is 6. 15 plus negative 10 is 5. So all you have to do is find the places that match and add them together. Now if we're looking at B plus C, we've already decided that we can't do that, but I want to show you why. If I have negative 4, 4, negative 3, negative 10, plus negative 2, 8, okay, so I could add the 4 and the negative 2 and then 3 and the 8, but what happens to my 4 and my 10? I don't have zeros over here. You can't just put in zeros because they don't exist there. So I just have these two left over and I can't just toss them out either. So this is not possible. Go ahead and turn to the next page. There are two more set up for you. I want you to go ahead and give them a try. I'm going to keep going, so you should pause the video and come back to it when you're ready. Alright, so we have a 2 by 3 and a 2 by 3 being added, so we know that we're going to get a 2 by 3 back out. I know that 7 plus negative 3 gives me 4. Negative 2 plus 4 gives me positive 2. 11 plus 5 gives me 16. Negative 14 plus negative 4 is negative 18. 8 plus 6 is 14. 1 plus negative 1 is 0. That's the end. Okay, down here I have a 3 by 2 and then a 3 by 2. So these can be added and I'll get a 3 by 2 back out. 12 plus negative 2 gives me 10. 8 plus 4 gives me 12. Negative 3 plus 1 gives me negative 2. Negative 7 plus negative 1 gives me negative 8. Negative 6 plus negative 9 gives me negative 15. 9 plus 5 gives me positive 14. Okay? And that is how you add them. The same holds true for subtraction. And that's what we talk about on the next page. So take a look. We have A, which is a 2 by 3, B, which is a 1 by 3, and C, which is also a 2 by 3. We automatically know we can't do anything with B because it's not the same dimensions as A and C. A and C, however, are the same dimensions. So looking at B minus A, we automatically know different dimensions can't happen. But I know that A and C do, so I have 4, negative 17, negative 2, 10, 8, and 6, minus 1, negative 3, 5, 10, 8, and 7. They're 2 by 3, so I'm going to get a 2 by 3 back out. 4 minus 1 is 3. 2 minus a negative is the same thing as plus a positive, so I get positive 1, 3, negative 7, 2, negative 1. All right. There are 2 more examples on the next page. Pause the video, go ahead and try them on your own, come back when you're ready. Okay, 2 by 2s, so we know we're going to get 2 by 2 back out. Get negative 4, it's negative 2, 17, 11. Down here I have a 2 by 3, so I'm going to get a 2 by 3 back out. 16 minus 21 is negative 5, negative 9, 7, 10, 7, negative 2. Okay? You're going to start running into a lot of subtracting negatives and adding negatives and those kinds of things. If you're still having a hard time with those, make sure you're using your calculator to double check your work. Go ahead and turn to the next page. We can also multiply matrices by something called a scalar, and it is just a constant. And scalar multiplication is done by multiplying each element of the matrix by the scalar. So all you have to do is take the number that you have on the outside, so we're going to set this one up so you see what I'm talking about, and multiply each of the numbers on the inside of the matrix by that number and change it. It's really, really simple. So this one we have 4 times A. They want us to find 4A. So we're going to write it as 4, and then we're going to write our matrix. So 4 times 2, negative 4, negative 7, 9, 1, negative 10, 8, and 6. So all I have to do is distribute this 4 to each piece on the inside. So I get 4 times 2 is 8, negative 16, negative 28, 36, 4, negative 40, 32, and 24. That's the answer. You get the same dimensions out as you started with. Go ahead and try the next 2 examples. I'm going to keep going, so you should pause the video and come back to it when you're ready. So I have negative 3 times negative 9, 5, 2, negative 2, 3, negative 11, 7. And I'm going to get 27, negative 9, negative 15, positive 33, positive 6, negative 21. Okay? Down here I have 1/3 A. So I take negative 12, 6, negative 3, 0. Take 1/3 times each of those, and I get negative 4, 2, negative 1, and 0. Okay? That is the end of the notes, and that's kind of an introduction to what a matrix is, and eventually we're going to start using them to solve systems of equations. And it doesn't get too much more difficult, but we will start seeing things where we start multiplying rows and moving rows around, but it's pretty fun. Go ahead and take a look at the homework. Don't forget to finish your 6-5 assignment, and I'll see you tomorrow in class.